Good day, everyone. My name is Bryan Ring, and we're gonna have a crash course on microprocessor architectures, CISC versus RISC. So, before we have to understand the differences between those two computer architectures, microprocessor architectures to be specific, we have to understand first the concept of the storage scheme diagram for generic computers. Here in this slide, we are going to understand multiplying two numbers in memory. So as you can see on your right side of the screen, we can see the storage scheme diagram for a generic computer. So I'm just going to move my camera so that you can see the entirety of the diagram. So let's dissect what this diagram is about. So as you can see, this is the main memory, which is divided into locations numbered from row 1 in column 1, row 1 in column 1, to row 6, column 4. So this is the main memory. We also have the execution unit, which is the one responsible for carrying out all computations. And then we have the registers, where only data loaded here can be operated by the execution unit. So let's dissect this diagram for a little bit. So data is to be stored in the main memory. For example, we have number 5, we have a string, like for example, string plant, or we have an integer 56 or a floating number 3.14 in one. We store those kinds of data in one of the cells in our main memory. And then if we want to manipulate or operate on those data, we have to input those data we have to transfer those data from the main memory onto the execution unit, as the execution unit is the one responsible for doing the operations such as addition, multiplication, all those simple arithmetic operations, or even the logical operations such as logical OR and logical AND. So we have to find a way for our data in our main memory to be transferred in our execution unit. However, the execution unit will only operate on data that is first stored in registers. As you can see here, we have 6 registers in our diagram. So the flow of data, if we want our data to be operated upon, is first it has to be stored on one of the cells in our main memory. Then we transfer them to a register, to a free register, where it can then be executed by the execution unit. So that is how we dissect the storage scheme diagram for a generic computer. So why do we need to understand that? Well, so here is the differences between the CISC versus the RISC. Let's start first with the CISC. CISC stands for Complex Instruction Set Computer. This can also be called the CISC. So the CISC approach, or we have the Complex Instruction Set Computer, or it can sometimes be called Complex Instruction Set Computing. So what is this actually? So the primary goal of a CISC is to complete a task in as few lines of assembly as possible. So if it is not even sure at this point, the CISC versus the RISC, the two different microprocessor architectures that we're assessing right now, those are two approaches that any microprocessor can utilize that can help it execute instructions or programs. So here we're going to tackle first the CISC approach, which is Complex Instruction Set Computer. Its primary goal is to complete a task in as few lines of assembly as possible. So the key word is few lines of assembly. So it has shorter instructions. That's what it wants. It wants to have shorter instructions, but it does have it. It should enable the same processes as its counterpart, the RISC. We're gonna explore that in a little bit. But first, why do we have to understand the storage scheme diagram? Well, one way to explain the major differences between CISC and RISC is by executing multiplication of two numbers using this diagram, using the storage scheme diagram. So a CISC processor would come prepared with a specific instruction. Okay, let's tackle first instructions on how to do the multiplication. So let's say we want to find the product of two numbers. The first factor is stored in location 2, 3. So as you can see, we have 2, 3, row 2, column 2 row 2, column 3, and then the second factor is to be stored at 5.2. So 5.2. So we have the data stored over here in our main memory, and then the product is to be stored in location 2.3. So going back to CISC, a CISC processor would come prepared with a specific instruction. So we'll call it molt, just for the sake of it. You can call it any, but let's just say it's called molt. It can also be mol, or depending on the assembly language. When executed, this instruction loads the two values into separate registers, multiplies the operands in the execution unit, and then stores the product in the appropriate register. So before I would explain this, let's finish this first. Thus, the entire task of multiplying two numbers can be completed with one instruction, mult 2352. So what does this mean? So in just one line of instruction, mult 2352, this means you have to multiply, this is the operator. We multiply the data on 23, on cell 23 and in cell 52. We multiply those numbers, and then it's gonna store the product in the appropriate register, which is in this case in the first parameter, which is 23. So in just one line of code, mult 23, it was able to do three things. It was able to load the two values into separate registers. It was able to multiply the operands in the execution unit, and then stores the product in the appropriate register. So to demonstrate the flow, it takes up the data. It takes the two data from the main memories, transfers them into the register, operates them in the execution unit, then transfers them back to the main memory. In just one line of code, it was able to achieve those three things. So a continuation, mult is what is known as a complex instruction. This is why CISC is called complex, since in just one line of instruction, which is mult, that is known as complex since it does a lot. It loads up the data, it stores the data, it operates on the data, then it stores the data. So those are a lot of instructions in just one word or in just one instruction. A complex instruction operates directly on the computer's memory banks and does not require the programmer to explicitly call any loading or storing functions. Again, it doesn't have to load or store, you just have to simply call mult. It will closely resemble a command in a higher level language. Higher level languages which we are familiar with, such as Java, C, those are languages that we are very versed in. For instance, if we let A represent the value of the data in cell 2.3 and B represent the value of data in cells 5.2, then this command is identical to the C statement. A is equals to A times B. So that is how multiplying two numbers is operated. Now let's go to the RISC approach, which is its counterpart, the reduced instruction set computer. That's what RISC stands for. It can also stand for reduced instruction set computing. So what is the primary goal for RISC? RISC only uses simple instructions that can be executed within one clock cycle. So what does this mean? So the major difference between the two is that in multiplying two numbers, we're gonna expound this in this illustration below. As you can see, we have the same instructions as in the CISC approach. But if you want to multiply two numbers in CISC, we only have one line of code, which is mult 2.3 then 5.2. Here, when we want to multiply two numbers, the mult command, there's no such thing as mult command. I mean, there can if you want to, if the assembly language has it, but its functionality is different. So as you can recall, mult does three things in just one execution of the code, in just one call of the code. However, here, the mult command is separated into three commands: load, prod, and store. Load, which moves the data from the memory bank to a register. So as you can see in the diagram, load is transferring the data from the main memory onto one of the free registers. Then there's also prod, which finds the product of two operands located within the registers. This is where the execution unit does its thing. Then store, which moves the data from a register to the memory banks. So if you continue, in order to perform the exact series of steps described in the CISC approach, a programmer would need to code 4 lines of assembly. Load A to 3, load B, load to register A, the data from cell 23, load to register B, data from cell 5-2, product, multiply the data from registers A and B, then store to cell 2-3 the data from register A. So this is how you, so compared to CISC only has one line of code, which is mult 5-2, 2-3 and 5-2. Here in RISC, it's actually dissected into 4 more, since the loading, the multiplying, and the storing of data is distinguished. They're different from each other. So let's continue to expound on the RISC. There are more lines of code in RISC, which means more RAM is needed to store the assembly level of language. The compiler must also perform more work to convert a higher level language statement into code of this form. So it's going to be more hectic for the RAM, for both the RAM and the compiler. However, because each instruction requires only one clock cycle to execute, the entire program will execute in approximately the same amount of time as the multi-cycle mult command. So even though it is longer, there are more lines and it is more hectic for both the RAM and the compiler, the amount of execution time for both CISC, which is the mult command, and the RISC, which has load, 2 loads, 1 prod, and 1 store, they both execute in approximately the same amount of time, since each instruction requires 1 clock cycle, whereas the mult command from the CISC will require multiple clock cycles. We're going to discuss the differences later. So to proceed, these reduced instructions require less transistors of hardware space than the complex instructions, leaving more room for general purpose registers. So this is for the purposes of hardware. So this is also very good for the hardware. Because all of the instructions execute in a uniform amount of time, i.e. 1 clock, pipelining is possible. Pipelining is the technique where multiple instructions can be executed at the same time. It's sort of like multitasking for the microprocessor. So RISC, reducing the amount of work. So you might think that RISC has more lines of code, therefore it looks like it's less efficient, but it's actually quite the opposite. Separating the load and store instructions actually reduces the amount of work that the computer must perform. Let me explain. After a CISC-style mult command is executed, the processor automatically erases the registers. So if one of the operands needs to be used for another computation, the processor must reload the data from the memory bank into a register. So this is its difference. Again, the mult command is executed, the processor automatically erases the register. So it's once you have finished executed the mult command, you're gonna have to repeat the data once again. You need to after each command it resets or it refreshes the registers. So you need to, if you're working with the same kind of data over and over again for the same set of commands, it's gonna take less efficient. It's gonna be less efficient for the microprocessor. In RISC, however, the operand will remain in the register until another value is loaded in its place. So the RISC is actually better for repeated sessions, or it's more efficient for the microprocessor. Speaking of efficiency, let's tackle the performance equation. The following equation is commonly used for expressing a computer's performance ability. So give me one moment. Okay, so the performance equation. The following equation is commonly used for expressing a computer's performance ability. So the time for the program equates to time executed per cycle, which is multiplied by the cycles per instruction. So which is multiplied by instructions per program. Let's dissect this a little bit. So the time for a certain program is going to be dependent on how much time is actually executed, how much time has on the duration of time per cycle, per clock cycle. Then this is multiplied by the number of clock cycles that is needed per instruction. And this is again multiplied for the number of instructions that a program has. So that is the equation for a computer's performance ability. Why do we need to tackle this? Because the CISC and RISC approaches the performance equations in different ways, all in favor of doing what's best to achieve utmost efficiency for a computer. The CISC approach attempts to minimize the number of instructions per program. sacrificing the number of cycles per instruction, whereas RISC does the opposite, reducing the number of cycles per instruction at the cost of the number of instructions per program. So just to recap, CISC has less number of instructions. However, it has less number of instructions, but it has more number of cycles per instruction. RISC does the opposite. It has less cycles, but it has more instructions. So they're both opposites. So to proceed, let's tackle the historical context between the two. So RISC methodology was developed at IBM in the late 1960s, where microprocessors weren't even invented yet. Yet despite that, until recent times, all the major manufacturers of microprocessors use CISC-based designs, were even invented. So majority of the time, majority of the microprocessors before use CISC. Why? Because microprocessors were introduced in the early 70s were mostly simple electronic products such as calculators, stereos, video games. They were not personal computers. So in these situations, the CISC technology were more suitable because, for example, calculators, they can also, let's tackle a simple calculator. They can only add, multiply, divide, maybe clear all, but those were very simple electronic products. There were no need to, it was mostly, the electronic products before were mostly used for one single thing, and they're very more specialized in that. So CISC is more appropriate for those. CISC is appropriate for specialized products. However, eventually, these CISC-based microprocessors found their way into personal computers. So this is the era of personal computers. The PCs evolved with generation after generation of CISC-based microprocessors being introduced to meet the ever-increasing demands of PC users. The microprocessor manufacturers began to refocus their CISC microprocessor design efforts away from general purpose to a high-performance computing orientation. So this is why in modern era, in modern times, RISC is more prevalent than CISC. Aside from RISC being regarded as more efficient than CISC, with CISC being the predecessor, RISC allowed modern computers to be to enable programmers and users, both programmers and users, to be more flexible in their commands. They were more efficient for the microprocessor, and they were more overall generally healthy for computers everywhere. Let's tackle the characteristics of CISC. We have actually tackled this before, but we're gonna do a recap. So the characteristics of CISC: instruction decoding logics will be complex. So for example, mult, the microprocessor does the hectic job of determining what the mult is, what the mult command does, which is 3 lines. Again, it was to load, it was to store, it was to multiply, and it was to store the product. So that's why it's complex. The microprocessor has to decipher what one line of assembly code has to do. One instruction is required to support multiple addressing modes. So one instruction, again with the mult. Less chip space is enough for general purpose registers for the instructions that are operated directly on memory. Various CISC designs are also set up to special registers for the stack pointer, handling interrupts, etc. And mul, or in this case mult, is referred to as a complex instruction and requires the programmer for storing functions. So the mult, for example, the mult complex instructions, it will require a programmer to actually define what mult does. As for this is also true for any complex instructions. Now let's compare it to the characteristics of RISC. RISC architectures use simple instructions, which is in comparison, which is in direct contrast to CISC, which uses complex instructions. RISC helps and supports few simple data types and synthesize complex data types. So what this means is they support few simple data types. However, using these simple data types, and let me recap. RISC supports few simple data types. However, with these few simple data types, they can synthesize or they can make complex data types. That's how RISC does things. RISC utilizes simple addressing modes in fixed length instructions for pipelining. So it does allow pipelining in RISC. I mean, it more incentivizes pipelining rather more in comparison to CISC. RISC permits any register to use in any context. So as long as the register is available and can be used in this architecture, there's one cycle execution time. So per instruction, it only executes one clock cycle. The amount of work that a computer can perform is reduced by separating load and store instructions. So in comparison to CISC, the molt command does 3 things, while load only does 1 and store only does 1. That's more efficient for the computer. And continuation for more characteristics of the RISC. The RISC contains large number of registers in order to prevent various number of interactions with memory. So they have more registers in compared to CISC. Pipelining is easy as the execution of all instructions will be done in a uniform interval of time, i.e. 1 click. So this is why pipelining is actually possible in RISC. In RISC, more RAM is thus in RISC, more RAM is required to store assembly level instructions. So it does have a little bit more, it does require more RAM. Reduced instructions need a less number of transistors in RISC. This is a good thing. This makes it hardware friendly. RISC uses Harvard memory model, which means it is Harvard architecture. So that is RISC. It hails from Harvard. Then a compiler is used to perform the conversion operation, meaning to convert a high-level language statement into the code of its form. Okay, so you will need a compiler to perform the conversion. Let's differentiate with architecture or comparison. CISC versus RISC. These are one of their major differences. So CISC, complex instruction set computing versus RISC, the reduced instruction set computing. CISC more or less emphasizes on hardware, while RISC emphasizes on software. So since the commands are usually, I'm not gonna say embedded, but it's more like wrapped or bundled. This makes code more reliant on the hardware. While RISC, it does require per line of instructions to be executed. So it's not bundled, instructions are not bundled. The CISC includes multi-clock complex instructions, while the RISC involves single clock reduced instructions only. So again, for complex instructions, for example, one line of command in molt, it requires 3 or more clock cycles in order to perform one instruction molt, whereas in RISC, it only requires 1 cycle per instruction. But again, you do have to write all those instructions down. CISC, or individually, I mean. CISC. CISC is memory to memory, meaning load and store incorporated to instructions. So, meaning memory to memory means the instructions, the instructions stored in the command is actually stored in memory, and then so load and store incorporated in instructions. You have to, for example, in one molt command, you have to retrieve the data from the memory. You have to operate in the execution unit, and then you need to store it back in just one line of code. Molt. However, RISC promotes register to register, meaning load and store are independent instructions. As we have recalled, load and store are different. They're not bundled into one single command, unlike molt in the CISC. CISC, small code sizes but high cycles per second. So again, this is a little bit repetitive, but CISC has fewer lines of code but more cycles per second, whereas the RISC, they have low cycles per second, but they do have large code sizes. Okay, transistors in CISC are used for storing complex instructions. So, for example, molt, it does 3 distinct operations or instructions. They use transistors to store those instructions, whereas for RISC, they actually use more on memory registers. So let's discuss the pros and cons of CISC. What are the advantages of CISC? Let's start with advantages. Microprogramming is easy. Assembly language is easy. Assembly language is an easy assembly language to implement, and it's less expensive than hardwiring a control unit. So it's less expensive and it's easier to implement. The ease of microcoding, new instructions allow designers to make CISC machines upwardly compatible. So CISC machines everywhere are usually very compatible. As each instruction became more accomplished, fewer instructions could be used to implement a given task. So fewer instructions, that's very good for the programmer. However, they have disadvantages. The performance of the machine slows down due to the amount of clock time taken by different instructions, which will be dissimilar. So again, one line of instruction does take a longer time, and then after per execution of a command, it does reset the register, meaning if you're gonna recall those kind of data again from the main memory, you're gonna have to store it again in the register, since again, the compiler or the microprocessor will just refresh or erases all the data in the register after each instruction or after each command. Then, only 20% of the existing instructions is used in a typical programming event, even though there are very specialized instructions in reality which are not even used frequently. So it's a waste. It's more like of a waste or a lost opportunity for the existing instruction set, for the existing instructions in CISC, since only 20% is usable, and unlike RISC, which is a lot of them are actually usable. The conditional codes are set by the CISC instructions as a side effect of each instruction, which takes time for the setting, and as the subsequent instruction changes, the condition bits. So in short, the compiler has to examine the condition code bits before this happens. As a side effect of each instruction, which takes time for this setting. Now we move on to the pros and cons of RISC. Let's start with the advantages. RISC allows freedom of using the space on microprocessors because of its simplicity. So the RISC gives the microprocessor more leeway for it to perform more. This is why, again, pipelining is possible in RISC. Many RISC processors use the registers for passing variables and holding the local variables. So RISC is very much, they very much utilize efficiently the registers available. So this is why RISC is good. And since the register is the one storing and passing arguments, holding local variables, it does take less time for the computer to actually fetch them from main memory, since they're already there on the register. If you want to store other data in a register, you just have to replace it with a new one, the data from the register. RISC functions use only a few parameters, and the RISC processors cannot use the call instructions, and therefore use a fixed length instruction, which is easy to pipeline. So the main takeaway here is that it's easy to pipeline, since they only use a few parameters. The speed of the operation can be maximized, and the execution time can be minimized. Very less number of instructional formats, a few numbers of instructions, and a few addressing modes are needed. So in comparison to CISC, the speed and execution, both the speed and the execution time can be adjusted if the programmer knows what they're doing, or if the assembly language allows it. Okay, and then we move on to the disadvantages of RISC. Mostly, the performance of the RISC processors depend on the programmer or compiler, as the knowledge of the compiler plays a vital role while changing the CISC code to a RISC code. So compared to CISC, RISC is actually more dependent on the software and the programmer or the compiler. Okay, you need to remember that, since it does require the programmer to remember all the correct lines of code in order to execute the same instruction. For example, think about it. If you want to multiply two numbers in CISC, you just have to remember mult. However, if you want to multiply two numbers in RISC, you need to remember to load the two different data from the main memory. You need to multiply, and then you need to store the product. While rearranging the CISC code to a RISC code, this is termed as the code expansion. The code expansion will increase the code will be increased in size, the quality of the code expansion will also depend on the compiler and on the machine's instruction set. So in short, to shorten this note, RISC code is longer than CISC code. To continue, the first level cache of the RISC processor is also a disadvantage of the RISC, in which these processors have large memory cache on the chip itself. For feeding instructions, they require very fast memory systems. This is one of their disadvantages. They would have to require a very fast memory system. RISC is very RAM intensive. This is why so. So that wraps up the disadvantages. And that will conclude my presentation. I'm Bryan and BS from BSCS3, and this is my project or assignment for ComOrg 32. Thank you for listening.